In this video, we're going to be talking about how to convert between decimal, binary, and hexadecimal. And my hope is that by the end of this video, you'll be able to spend less time converting values and more time just interpreting them. Whether you're just learning how to convert between different numbering systems right now, or you just need a quick recap like all of us need at some point, I hope you find my explanations useful. So with that being said, let's go into a quick review of how the different numbering systems work. Binary is a base 2 numbering system, decimal is a base 10 numbering system, and hexadecimal is a base 16 numbering system. And the base represents the number of values you can use in the numbering system in each place. So when you're dealing with binary, which is a base 2 numbering system, you could use two possible values in each place, a 0 or 1. And in decimal, you have values 0 through 9, and in hexadecimal, you have values 0 through F. Now, if you're wondering what the letters A through F represent in hexadecimal, they represent decimal values, but you're representing them with one letter or one character, so you could put them in one place in the base 16 numbering system. So A represents the number 10, B 11, C 12, D 13, E 14, and F 15. So now that we got that out of the way, let's go over how to convert between binary to decimal. So when you're working with binary and analyzing binary, you're going to be looking at bytes often. So I used a byte in this example. One byte's made up of 8 bits, and each bit is represented by a 1 or a 0. I showed some examples of binary values such as 1, 1, 1, 1, 0, 0, 0, 0. And the way you're going to convert from binary to decimal is you're going to multiply the rightmost bit, so the one furthest to the right, by 2 to the 0, which is 1. Then you're going to multiply the next bit to the left by 2 to the first, the next one by 2 to the second, and so on. And then after that, you're going to add all the values you got to get the decimal value. So let's take a look at converting binary value 11000010 to decimal. So I lined up the binary values with their appropriate place and their appropriate numbers that they're supposed to be multiplied by. And I also wrote the decimal representations of what those values would look like, just to make it a little easier. So if you look at the example on the bottom where you multiply 1 by 128, you get 128. So then you multiply 1 by 64, you get 64. Then when you multiply 0 by 32 or 0 by 16, 0 by 8, or 0 by 4, you're not adding anything. Then you have to multiply 1 by 2, and you get 2. And then you multiply 0 by 1, you don't add anything. So altogether, you're only adding 128 plus 64 plus 2. You get 194, which is the decimal representation of 11000010. And converting from hex to decimal isn't really that different, and I'll explain why in a second. So hexadecimal, 1 byte is made up of 2 hexadecimal numbers, and I'll show you that below. Some examples of hexadecimal numbers are 0A, FF, and 10. The same steps are used to convert hexadecimal to decimal as they were to convert binary to decimal. But the difference is you're using a base of 16 instead of a base of 2. So when you were converting from binary to decimal, you were multiplying the bits by 2 to the 0, 2 to the first, 2 to the second, and so on. When you're dealing with hexadecimal, you're going to multiply each bit by 16 to the 0, 16 to the first, and so on. So let's take a look at 1 byte in hexadecimal, and we're going to be looking at the largest possible hexadecimal value you could have for 1 byte, which is FF. Remember that F represents decimal value 15, and that's the highest possible value you could go to when you're in one place when you're using a hexadecimal numbering system. So in this example, we're converting hexadecimal FF to decimal. I lined up the F and the other F with 16 to the first and 16 to the 0. So when you multiply F, which is equivalent to 15, by 16 to the first, so 15 times 16, you get 240. When you multiply F, or 15, by 16 to the 0, which is also 1, you multiply 15 times 1, you get 15. 240 plus 15 is 255, and that is the value for FF converted from hexadecimal to decimal. Now, just to point something out, I want you to notice that the max value of two hexadecimal numbers is 255 in decimal. If you were to calculate the max value of 8 bits in binary, which would be setting each of the 8 bits to ones, you would also get 255 in decimal as well. You would be doing 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when you add that up, you'll get 255. Alright, now that we've gone over how to convert hexadecimal and binary to decimal, I want to go over how to convert decimal to binary and hexadecimal to binary. But we'll start off with converting from decimal to binary. And to explain it, I'll use a mildly confusing analogy. So with the method I use, converting from decimal to binary is like playing blackjack, except the number you are trying to reach without going over or busting is your decimal number instead of the number 21. And you can look at the dealer's cards before choosing them, so you know what cards you're picking. And from left to right, you're going to put ones in the place of the largest value you can add or take without going over your number, and put zeros in the places where you cannot add a value without going over your number, which is basically where you can't take that card. So in this example, we'll convert decimal number 232 to binary. So if you take a look, the 2 to the 8th place represents the number 256. And since 256 is higher than 232, we can't put a 1 in this spot, so we have to start in the next place. We go to 2 to the 7th place, which represents the number 128, and it is the first possible value we could put within 232. So we put a 1 there, and then we need to do the same thing for each place after that. So looking at the bottom, we have 2 to the 7th going over to 2 to the 0. We could add 128, and we're still good. We could add a 64, and we get 192. And we're still good. We're still under 232. We haven't reached it yet. We could add a 32 to 192. We get 224. We're still good. Then we try to add 16 to 224. We get 240. That's going over. We can't take that card. We can't take that 16 card. We put a 0 under it. But we can add 8 to 224. We're going to take that 8 card, and we get 232. And that's awesome. That's our number. If we tried to add anything more after that, we'd be dumb because it's going over. So we can't take those extra cards. We put zeros in that spot. So hopefully that makes sense to you. That's just how I like to think about it. I think if you pay attention to the little table I made on the right, then you might be able to understand what I'm trying to get at. So, with that being said, let's move on to converting from hexadecimal to binary. So, to convert between hexadecimal to binary, the first step is you're going to separate each hexadecimal number. You're going to rewrite each of them in binary, basically using the steps from the previous slide. You're going to convert the decimal representation of the hex numbers to binary. And just to make a point, it's not ever going to be anything too bad because the max value you're going to be dealing with in binary is 15, which is represented by 4 bits set to all ones. So you're not going to have to do any extreme calculations. You'll just have to get used to figuring out the binary representations of the numbers 0 to 15. Then once you convert those decimal values of the hexadecimal numbers to binary, all you're going to do is snap them back together as they are. So you see, you snap the 1010 with the 0000 with the 0011 and the 1100. Okay, so the last topics we're going to cover are converting from binary to hexadecimal and converting from decimal to hexadecimal. Of the two, converting from binary to hexadecimal is easier, at least in my opinion, so we're going to cover that first. To convert from binary to hexadecimal, you're going to reverse the process that we use to convert hexadecimal to binary, but there's a catch. You'll want to convert the 4-bit nibbles, and nibbles just mean a set of 4 bits, from right to left. The reason why is because if you converted from left to right, and the number of total bits is not a multiple of 4, then you would mistake a smaller set of bits for the leftmost bits of a different nibble. So in this example, we're going to be converting binary number 101101011010, which is 5AA in hexadecimal because I looked it up. So the first example on the top shows you what would happen if you took nibbles from left to right. What ends up happening is you end up interpreting the first hexadecimal character for being represented by 1011, which is 8 plus 2 plus 1, that's 11, which is represented in hexadecimal as B. And then the next nibble represents the number 5. The next nibble, well, it's not actually a nibble, but the next set of bits represents the number 2. So you would end up snapping them together and getting B52, which is not 5AA. So if you convert from right to left, you grab a set of 4 bits, you get 1010, that's an A. The next set of 4 bits is 1010, that's an A. And then the last 3 bits on the left represent 5. So you snap those together, you get 5AA, which is the hexadecimal equivalent. So decimal to hexadecimal is a little bit more complex, but nothing too bad. You just will probably need to pull out a calculator, at least I need to. So the first step you're going to do is you're going to take your initial decimal value. For example, at the bottom, I said that we're using decimal value 5063. You take your initial decimal value and divide it by 16. You write down the quotient to the side, and the quotient is the largest integer that can go into the decimal value without going over, while dividing by 16 in this case. and then you write down the remainder, which will be the difference between the quotient times 16 and your decimal value. You're going to repeat step 1 while using the quotient as your new decimal value until you get a quotient of 0. Then, going from the bottom to the top of the remainders, you're going to write the remainders from left to right. As you see at the bottom, you have from bottom to top, it's 1, 3, 12, and 7. So you'd write those from left to right. And then you're going to convert the decimal values to their appropriate hexadecimal values where appropriate. So 1, 3, and 7 are good, but there's no such thing as a 12 character per se in hexadecimal. It's represented by the number character C. So as you can see in the example, we're converting decimal value 5063. You divide 5063 by 16, and the largest integer that could go into 5063 when dividing by 16 is 316. And 316 times 16, let's see, I'll do the calculation real quick. .316 times 316 times 16 is 5056. The difference between 5063 and 5056 is 7. So that's the remainder. As I stated in step 2, you're going to take the quotient, which is 316, and now it's going to be the new decimal value that you're working with. So you divide 316 by 16, you end up getting a quotient of 19 and a remainder of 12. Then you divide 19 by 16 and so on until you get a quotient of 0, as shown in the bottom left. And at that point is when you, from bottom to top, arrange the remainders from left to right, convert any decimal values to their appropriate hexadecimal values, and you'll end up snapping them back together, and you get 13C7, which is the hexadecimal conversion of 5063 in decimal. I know we covered a lot in this video, so if you have any questions about any of the material I covered, please feel free to leave a comment and I'll get back to you. Thank you for watching and have a good day.